This is BYU Math 112. In this video we will discuss textbook section 2.7, a problem like online exercise number 3. The problem we're going to do states, suppose that a ball is dropped from the upper observation deck of the CN Tower, 450 meters above the ground. Part A asks, what is the velocity of the ball after 5 seconds? Part B, how fast is the ball traveling when it hits the ground? So for part A, we have our formula for velocity given as the limit as h approaches 0 of the s of a plus h minus s of a all over h, where s of t is given by 4.9 t squared, the formula for distance traveled at a certain time when a ball is dropped or anything is dropped with no initial velocity. So we're going to figure out part A. We're going to find the v of a, because we're going to use it again when we do part B. So in a general way, we have the limit as h approaches 0 of 4.9 times a plus h squared minus 4.9 a squared over h, and multiplying out on the top, we're going to get 4.9a squared plus 9.8ah plus 4.9h squared minus 4.9a squared, again all over h. Well, we note on the top that the 4.9a squared minus 4.9a squared is going to cancel out, and we also notice that both of these terms on the top have an h, which is going to cancel with our h on the bottom, and so we will have the limit as h approaches 0 of 9.8a plus 4.9h. And again here we note that the limit of the sum is the sum of the limits, and since this is multiplying by an h, this is going to go to 0, and so when we're done we're going to have that the velocity at any time a for this problem is going to be given by 9.8a. In this case, we're looking at a equals 5 since it's after 5 seconds. So v of 5 is 9.8 times 5, which is 49. In this problem, our units are meters and seconds, so velocity is 49 meters per second. That's our answer to part A. Part B says, how fast is the ball traveling when it hits the ground? Well, first we have to figure out how long it takes to hit the ground. We know that for some time, t1, given by 4.9 times t1 squared, that's going to be equal to the distance that it travels to hit the ground. Well, we said it was dropping from 450 meters, so we're going to figure out when 4.9 times t1 squared is equal to 450. So solving this equation, divide by 4.9 on both sides of the equation. Those cancel out. We have t1 squared is equal to 450 over 4.9. And the way we get rid of squaring something is to take the square root of both sides. And we get that t1 is equal to the square root of this 450 over 4.9, which comes to something in the ballpark of 9.6 seconds. So now we know how long it took. The problem asks how fast is the ball traveling. So we're going to take this time, 9.6 seconds, and use our formula for velocity again to find v of 9.6 is given by 9.8 times 9.6, which gives us something in the ballpark of 94 meters per second. So that's how we do something like online number 3.